fourth step of metallurgy, or you can say another use of electrolysis is the electrolytic refining, right. So again we will split this whole term into two things. What is refining? Refining means the conversion of impure metal into a pure metal, right. Electrolysis, when we are doing the refining by involving the process called electrolysis, then it is electrolytic refining. That means it is a process in which we purify the impure metal into a pure form by using the process electrolysis, that is the electrolytic refining. So what kind of apparatus, what kind of anode, cathode, electrolyte we are going to take place? So just look at the board. So again here is an electrolytic cell. As you know that electrolysis are always carried in electrolytic cell. So obviously it is an electrolytic cell which possess the electrolyte, which has the electrodes, has the wires, and to which the battery is attached. The electrode which is attached to the positive pole act as anode, it is positive pole, and the electrode which is attached to the negative terminal obviously act as a negative pole, right. So you know that the basic or the general phenomena of electrolysis always remains the same. What changes is the material of anode, cathode or electrolyte, or we sometimes add certain substance to it, to an electrolyte. This is how what it changes for the different process, like it was electrolytic reduction, it was electroplating, it was electrorefining now. So this is the basic change, is the only in the change in the anode, cathode and electrolyte. Moreover, the whole process remains the same, that is the basic thing always remains the same. So see, in this figure or in this process electrolytic refining, what we are going to take cathode, anode and this electrolyte. So the cathode is made up of pure block of metal. That means the metal, like the metal which we need to purify, that metal pure block is made as cathode, and anode is the impure block of that metal, and the electrolyte is that metal salt solution, any metal salt solution. So to just make you more understand this concept, I am taking an example of electrorefining of copper, right. So that means cathode is made up of pure copper, anode is made up of impure copper, and this is a metal salt solution. So the example which I am taking is aqueous CuSO4, right. So you know that if these are taken, like I will write here also CuSO4 aqueous solution as an electrolyte. So again the same thing is going to happen, that when we pass in electricity, this salt solution will just get dissociated into ions. So see, here I am doing for you, on passing electric current, it will get dissociated into respective ions. And as we know it is an aqueous solution, so that means water will also get dissociated into its respective ions. Now as you know that the positively charged ions move to negatively charged pole, that is the cathode, and the opposite the negatively charged one moves to the positive charged pole, that is the anode. And there they perform their general basic reactions of oxidation and reduction. So what kind of reaction we get to see at cathode, and what kind of reaction we get to see at anode? So on anode, which ions migrate? Sulfate ions, hydroxide ions, and don't forget it is obviously made up of the impure copper. So that means it too has the copper atom. So out of these three ions, which has the low discharge potential, you know that is going to get discharged. And when we compare their discharge potential, you know that copper has the lower discharge potential. So that means out of these three, copper is going to undergo a chemical change. So what is going to happen? This copper will lose its 2 electron and just get converted into the ion. So that means here what we see, we get to see that here Cu2 positive ions are formed. And where do these Cu2 positive ions go? They go into the solution, and the solution already has, you know that Cu2 positive and sulfate ions. So that means the concentration of these Cu2 positive ions are going to increase in the solution, and then these Cu2 positive ions, as you know that at cathode Cu2 positive and hydrogen ions go, and out of them the Cu2 positive ion has a lower discharge potential. So obviously it is going to discharge and show a chemical change. So this Cu2 positive, what kind of chemical change it can do? You can see that it has 2 positive, that means it has already lose 2 electrons. So it will just acquire its 2 electrons back. So it is just taking 2 electrons back and turning into the pure copper metal. And so this is this kind of reactions, that means the oxidation take place at cathode and the reduction take place at cathode. Right, you know that the same reactions which we were doing in electrolytic reduction, in the basic electrolysis, or you can say in the plating, the same one are applicable here as well. So that means these Cu2 positive ions are moved here, and what they do, they just gain their electrons back, that means reduction, and this kind of this will get coated with the copper, pure copper. So this is how this kind of chemical change we get to see, and what why we were just performing this experiment, because we need to purify this impure block, and this we have already done, because see this block starts getting dissolving because it is just getting converted into the ions, and that ions are just going into the solution, and along with the more Cu2 positive ions which are present in the solution, they are going to the cathode, where they are just gaining their 2 electrons back and changing into the copper metal, and that purified layer is coated on the cathode. So that means at the end of electrolytic refining, the pure metal is always obtained at cathode, and moreover the impurities which are present in this the impure block will just get deposited under the anode like this, and it will be called as anode mud. So this is how we do electrolytic refining, or you can say it is the 4th step of metallurgy, or you can say it is also in use of electrolysis. That means the refining, purifying the metal by using the process electrolysis, right.